So today I'm going to talk about a plugin we developed, and this was a collaboration between where I actually work, a daytime job, at the Brazilian office of the Comptroller General. We do audit inspection there, so we deal with where the money is going and people are spending it correctly. And together with the University of Brasília, with some professors and students there. So basically what we developed is a plugin that helps us. It's a tool for documenting, maintaining, and evolving probabilistic ontologies. As far as we know, this is the first type of tool that does this. I know it's still in early stage, but the ideas, I think, are promising. So I'm going to discuss that in a little bit more detail. So the agenda is going to be, give a brief introduction about what we're going to be talking about. Then talk a little bit about the uncertainty modeling process for semantic technologies. So it's basically a guideline for creating these probabilistic ontologies. And also talk about just a little bit about the architecture, the plugin architecture we have in UnBBayes, and the type of plugin we created for this type of tool. Then I'll show you a use case which is related to my work in fighting procurement, fighting frauds in procurements. Public procurements, to show how this tool can be used and so on. So that's basically what we're going to be talking about. So again, feel free to stop at any time if you have questions, if you want to clarify something. We don't need to wait until the end. We can, you can interrupt me anytime you want. Okay, so a little bit about the introduction. So basically, and I'm calling here the big bang of logic plus uncertainty, is that in the past few years, I've seen a lot of different languages being proposed for extending logic to deal also with uncertainty. And basically, those that work with Bayesian networks, they've extended ontologies or logic or description logic to deal with uncertainty in a Bayesian network kind of way. And those that deal, are used to dealing with fuzzy logic, they did the same thing for fuzzy logic and so on. So you see a lot of different implementations or languages being proposed for all these different types of ways to deal with uncertainty, right? So basically, we've seen all types of, and here it's just a few. I mean, there are a lot more than what I'm showing here. And these are just a few that extend actual, not pure logic, but some kind of OWL language or some subset of it, and extended to deal with uncertainty. So we have probabilistic OWL, which was proposed by Costa and extended by myself on which was the PROW2 version. We have OntoBayes, we have Bayes OWL, some probabilistic extensions of Schiff, Schoen, and we have a lot more than that. We have some fuzzy extensions also, and so on. I didn't put everything here, but there are tons of them. So basically is, creating ontologies is already something that it's not trivial. It's not simple. Creating real ontologies is something that it's hard to do. Sometimes you have this idea that you want to do, and the domain is just huge. And sometimes you don't even know where to start. And also creating models for instance, Bayesian networks, or even fuzzy systems models and so on, or neural networks, or anything you can think about that it's uncertain. It's also something hard, right? So you have all these knowledge experts that know how to create these models, and something hard, and you have to elicit the probabilities, and you have to create these models. So imagine putting both together. So this can get really complicated to create this type of model. So this definition by Costa. He talks about what an ontology is. So basically, we're talking about a formal knowledge representation to express some knowledge about a specific domain. Application. So we have things like types of things, right? We have classes. So we have, for instance, in our scenario, we're talking about a person, an enterprise, a procurement. We also have attributes for those classes, right? And have properties for them. So we have a first name of a person. We have the last name. We have the procurement number, and so on. So those are the types of things we see in an ontology. We also have relationship between those classes. So a person is a mother of another person. An enterprise is participating in a specific procurement. person is owner of certain enterprise and so on. And we also have processing events that happens with those entities. So you can also model or define the semantics for analyzing if the requirements are met or choosing the better proposal or something in that sense. When we add probability to it, what we basically are doing is we are also adding all these different types of uncertainty to these terms, to these semantics we have. So we're going to talk about statistical regularities that we have on that domain, inconclusive, ambiguous, incomplete, unreliable, and you can think about a lot of different uncertainty associated to that domain. So we've seen a lot of that on the first talk for who was here, that Annie gave a talk about all these different types of uncertainty, and who was here saw that there are tons of them. Right? So basically, what we're trying to do to be more practical, right, pragmatical, is that we're trying to say something, for instance, that the probability that the person is upfront for a certain enterprise, given some piece of evidence. So given some data I have, some triples I have in my triple store. For instance, that the value of a procurement is greater than $1 million, and we are talking about a procurement which this enterprise won, right? Because then the money went to that enterprise. And then the owner of that enterprise doesn't make even $10,000 a year. So you're like, okay, his company makes millions, and this guy doesn't even get paid $1,000 per month. So, it's pretty likely he's upfront for that enterprise. So that's basically the type of reasoning you want to do. Because if you deal with just standard logic reasoning, you're just going to ignore that, right? Oh, is there a front for this enterprise? Well, I don't know. The data doesn't give me information enough to get to that conclusion. So we want to take advantage of the information we have, those pieces of evidence, to be able to actually infer something about the things that we're not certain. Okay, so that's what we're trying to do. But this is hard to do. This is hard to model. It's hard to create these models. And it's not always the case that you can learn this from data, right? Because what we see a lot when talking about machine learning and all is that you give all this data to the algorithm, and then it learns the model that you can apply, and you can test it, validate on a different set of data, and see, okay, it works or it doesn't work. It generalizes well or it doesn't. But sometimes, we have tons of data where I work. So we have pretty much all different databases from all different agencies in the government. But when we put them all together, it's like, okay, where's the fraud? I don't know. Nobody told me before. It's not like tagged. Oh, here's a fraud. He's not a fraud. And this guy's a fraud. This guy's not a fraud. So how do I do it, right? So all we do have is some expert knowledge of, what are the kind of rules or what are the kind of things people do or workarounds they find in law in order to be able to steal some money. So what we want to do is put that information into a system that is coherent. It's not going to do weird stuff, right? And it's going to allow me to scale that type of reasoning to something that deals with tons of data. Okay, so that's something we're trying to do. And while I was doing my PhD work, I got a lot of questions from a lot of different people from all over the world. So basically, they were talking about, my objective is to define and represent the context model for interoperability of sensory networks. So it's totally different scenario than what I was dealing with. Basically, he's saying it's being a little bit hard to understand how to put in practice a probabilistic ontology. So, in his case was even worse because he had not really a good background in computer science, which makes it harder depending on how you approach this. So we had some other people saying, okay, this seems to be very promising. This seems to be really interesting work. And then he's talking about UnBBayes, which is an implementation of one of those languages that we talked about, PROW, Probabilistic Ontology, Probabilistic. So he goes about, how do you identify which entities are relevant to the problem you're talking about and how to translate them to variables of your system? So how do you model that to the language you actually have? And those questions kept coming in different ways, but they're all talking about how do I create this model, right? So you have, okay, I'm trying to evaluate this PROW language, but I'd like to explore if and how it can be used for applications, use resource devices. I have this domain and it seems to be useful, but how do I actually see if it fits or not? You had some kind of guideline, and some other people kept give me questions. It's hard to answer. It's like, why use these variables? Why they are connected in such a way? How do you choose what type of variable it is? And so on. And basically, I had some papers published on some use cases I created, some fictitious ones, some real data ones we had. And people said, okay, how did you come up with that model, right? So in the end, how one reached from a problem description to a model. A MIBN model, it's the logic that has first-order logic plus uncertainty. So it's behind the Pro language. So it's a multi-entity based on networks. So sometimes it's not very clear what it is and how to do it. Should we follow an object-oriented approach when identifying important entities, or should we think in terms of predicate logic? How do I approach this? How is, what's the thinking process? What drives our thinking process? So that led me to actually propose a modeling process. It's still not complete enough as I would like, but it's what I called on my PhD thesis, uncertainty modeling process for semantic technologies. And basically what it does is describe the main task involved in creating probabilistic ontologies. So how do I go about defining this? I have this description of what I want to do, and how do I break it down into chunks that I can actually get to the other side, right? But it's only a guideline. So how can something help me actually do this step by step and not lose myself in the process, right? So that's what we're trying to do with this plugin. So it's basically a tool that tries to solve three main problems, which is the complexity in creating these probabilistic ontologies, because you start creating a bunch of objectives and goals you have, and it's kind of hard to put the pieces together. So you have to be able to do that, and a tool helps you do that. A difficulty in maintaining and evolving existing probabilistic ontologies. But basically what you do is, so you don't get lost, you want to finish something, right? So it's pretty similar to software development. Sometimes you just divide it in different iterations, right? And you do the first iteration, you have something working. You can test and see if you're going in the right direction or not. And then you do another iteration where you might change some code that you implemented at first, but also you're implementing something new. And how do you keep track of what's going to be the impact in whatever you did before, right? And also, when I did this, a lot of times I would have UML diagrams, and I would have some documents, Word documents here and there, or LaTeX documents or whatever. But I would have pieces of documentation all over the place. I would have in scribbles on papers, and I would scan that just not to lose the idea. And it's hard. It would be better if I had a centralized way of documenting and keeping track of that. Basically, what is this process I'm talking about? So this is a well-known figure. This is not mine. Just, I drew it myself, but it's not my idea. This is from the unified process, software development process. So basically what you do have is, you have different phases, right? So like the beginning of the project is where you have the inception of the project, and then you have the elaboration, the construction, and then the transition. And depending on which phase you are, you're more focused on a specific discipline than the other. So in the beginning of the project, during the inception phase, you're more worried about requirements, right? Defining your requirements. But the requirements you're going to define and change all over, during the whole process of your project. But of course, in the beginning, it's going to be more heavily intensive, right? And the same thing goes for analysis and design. Analysis and design starts a little bit later in the process, but it goes all the way, and implementation and so on. So what we also have here is the iterations. So the iteration is like you go through all these different disciplines, and you start and finish something, right? So you can actually test a piece of model you created, even if the model is really simple, just a rule, a probabilistic rule you have defined with a really simple ontology, and then you're able to test a little bit, see if it's actually behaving as you expect. And then if it is behaving as you expect, then you go to the next iteration and try to implement the next rule, and so on. So that's basically the idea behind doing this. Okay, so how does this work with this probabilistic ontology modeling? So basically, let's just focus in one iteration, right? So what we have here is, and here I keep the colors the same. So blue is requirements, green is implementation, analysis and design, red is implementation, and purple is testing, okay? And The way I tried to do this, and for every use case I created, is basically you need to define your goals. What is your model supposed to do? What do you expect your model to be able to answer you in the end? So what is the kind of thing you're trying to let your model reason about, right? So those are my goals. But, so for my use case was find suspicious procurements. But then if you tell your model or someone to create a model, say, okay, create a model for me that finds suspicious procurement. He's going to say, I have no idea. Where should I start, right? So what is the type of question you expect the model to answer? What's going to help you identify if this is suspicious or not? What is suspicious? What is not suspicious, right? So you try to find queries that you would be able to ask the model. And then the model would say, okay, the probability of this query being true or false, or if that's the case, it's 90% or 70%. What is the type of question you would expect the model to answer? So one of them could be, is there any relationship or any relation between the committee and the enterprises that participate in the procurement? Right? Why? Because, well, if they're related, then you could be directing because it's your friend, and then you would like your friend to get some money because he's broke, poor guy, right? So that's something that lets you know if it's suspicious or not. But it's not easy to answer that question. How do I know if two people are related? Oh, it's going to be on the triple, your RDF or model or your ontology, you have their brother, right? But do I really have that information in my database? Usually, I don't, right? Even mother, which is something that we expect to have. In Brazil databases, we just have the name of the mother. And we don't have an ID for the mother, at least not attached with the son or the daughter, right? So what happens? We have a lot of Marys, right? So we have a lot of people with the same name. So we can't really say if it's the same mother, right? It's the same person. So I can't really say it's the same as, although it's the same exact string. They might be different people. So I can't really say that this person is brother or sister of this other person, right? So that's a problem. But hey, I would like to know if you're siblings. But that piece of evidence could actually be a question in itself. Could be, okay, are they siblings? And how do I know that? Oh, you see if they have the same mother, and if you have data about the mother, then you could go on and on. So this is not just a three-phase kind of thing. An evidence to a query could be another query. And then to answer that query, you could have another piece of evidence or another query you should ask. So it really depends on how complex your model is. But here I'm just showing, goal, query, and evidence, but it could actually be really long kind of thing. And the other thing is, do they live in the same address, right? So if you expect people to live in the same address, they should be related, right? At least good friends. Because if you're, or be in the same financial situation, that makes you split the rent, right? So at least you know that person. In Brazil, at least, we have a lot of people that work for you, like maids and babysitters, that actually live with the person. So they come from a really poor place or city or neighborhood, and they move to that city just to work for you. So they have no place to live. So just because they live on that address does not mean that you're related to them, right? So that's why we also have uncertainty here. We can't say, no, I know for certain. If they live in the same address, they must be related. There's also the problem of time frame, right? Maybe the data you have doesn't have time associated with it. So, you may think they live in the same address, but they're different years, right? So this person was renting this property, and then he finished his PhD, he went back home, and then this other person got that same place. So you have to deal with that too. But anyway, that's a piece of evidence you can use, right? So you have to do that for all the different kinds of questions your model could answer, right? And then once you look at those queries and goals and so on, you try to identify keywords that it's going to show you what are the kind of things you're going to need to have on your ontology. So you see that we're talking about person, the procurement, you have enterprise, you have the owner of the enterprise, you have the person responsible for that procurement, you have the person lives at a certain address, and you have the address and so on. So you try to create all this different keywords that are going to become your ontology in the end. So here I'm not too worried about the ontology itself, so all the subclass kind of thing yet. just want to create some kind of documentation of the things you need to worry about when you create your ontology. And there is a really big literature on how to create ontologies. So I'm not going into that. I want to go more into the detail on creating the probabilistic side of things, right? So the next step for me would be to create these rules. And of course, we have the deterministic rules and the stochastic rules, right? So it's interesting to put both there in your documentation, but I'm going to talk a little bit about the uncertainty part of things here. So for instance, I would say that if a member of the committee lives at the same address as a person responsible for the specific bidder that is bidding on that procurement, a relationship is more likely to exist between them, which lowers competition. So if it lowers competition, then it's more likely that I have a suspicious procurement, because procurements are supposed to be highly competitive, right? So that's the kind of reasoning I want to do. So I want to create all these different rules. Once I do that, then this can get really ugly, right? You're going to have tons of entities and properties and so on. You're going to have tons of evidence and queries and rules. So you want to try to group them into something coherent and that it's logically talking about the same thing. So, for instance, I want to group all the things that talk about personal information, all the things that talk about enterprise information or procurement or whatever. You can group this in any way you want. This is going to make your life easier when you try to implement this in specific language, right? So all this work up to this point is language independent. So it doesn't matter if I'm using UnBBayes, Prowl, fuzzy implementation of that language or whatever. This is just like helping you drive your thinking process to create these rules, and then you can implement it. So if you implement it in Prowl, then you're going to have to think about certain things, and this is what I'm talking about here. So it's going to map these entities, mfrags, and nodes and relationships. So these properties are going to become random variables, and then the if-then rules are going to show that you have a link between the two different random variables and so on. So for instance, here, I have a link between the lives at the same address or are related, which means if they live in the same address, then they are related, are more likely, right? So that's the kind of structure I have to create when I do this mapping. And later on, of course, I do have to give the numbers to this. So I could use the data to do some learning, or I could just elicit from experts. And we also have a bunch of papers here on how to elicit these probabilities, right? On, for instance, Bayesian network papers that talk about this. In the end, of course, you have to create the use cases that you're going to test to see if it's reasoning as you would expect. So you put all these different rules together. Am I getting the right result in the end? So is this reasonable enough? So I have to create different scenarios. Of course, if I have the data available that I could actually just test and see if I got it right or not, then I can do the confusion matrix and see if I'm doing good or not. But in some cases, you don't have that, right? So I also worked for the Navy in the US during my PhD, and we were dealing with problems as terrorist problems, right? So trying to find terrorist boats in the sea and those kind of things. Well, we didn't have ground truth to do the confusion matrix. So it did have to see if our reasoning was actually, if the model was behaving as expected, right? So we had to create different scenarios where this seems to be a terrorist, but it's not really a terrorist. What is my model going to think, right? So those are the kinds of scenarios we have to think about when doing the testing. Okay, so the plugin itself is just going to focus right now, and it just focused right now on this language independent part of it. So it's defining the requirements and the analysis design phase. Right? So what we did, and of course, one really important thing that I haven't talked about yet is that we have to have traceability. We have to have requirements traceability. So what I really want to do here is to know, okay, if I change this requirement, if I change this evidence or this goal, whatever, just remove this goal, remove this query, what's going to be the impact on my model? Right? Is it going to change a lot? What's going to be the possible impact? Okay, you might be careful because you might have to remove this entity, or you have to might have to change this grouping or whatever. We have different ways of different layers to worry about the specific property that you might have to change or remove, or a whole bunch of rules that you just throw away because now you remove that goal from your model, right? So you have to make sure you keep a track of that. So the plugin architecture, what we have done, and I'm just briefly going to talk about this, is that it's pretty much like Eclipse. You just get this set of classes and resources, and you copy and paste into a plugins folder. And then when you load the tool again, it's going to load all those classes automatically. right? And of course, to do that, you have to extend certain classes. For instance, in our case, we were not implementing a new algorithm for Bayesian networks. We're implementing a whole new tool inside of it. So we create a new, what we call a new module inside UnBBayes. So implement classes that allow you to create a brand new module inside that tool. Okay? So I'm not going to into much detail here. We can talk about this later. But basically, the tool, what it does is actually allow you to enter all these goals and queries and so on. So we have things like the description of whatever you're inserting in your model. For instance, the entity description. And then you can add things like meta information. For instance, what's the author, the date created, what's the comments associated to that. You can do manually backtracking. So, for instance, you can say that this query is associated to that specific goal, right? And it can be associated to more than one goal, the same query. And you can also say that this evidence is a piece of evidence that is going to support that specific query. And then since you already did the query to the goal, you're going to have some indirect backtracking. So you don't need to do this for all the different levels. You just do it for the previous step, and automatically you have this chain of traceability you can keep track of. If you do this, when you talk about requirements traceability, people talk about like Excel files, keeping track of all this stuff, but it can get really complicated if you do that. So having a tool like this helps a lot. And we also did a little bit of automatic backtracking, so looking at keywords and things like that, to try to do that automatically for you. Okay, so we have some other things, attributes and reference that we have associated to that. So in the end, what we're trying to do is, for instance, the requirements. We have all these requirements here, and they're going to become entries in your model description, right? So you have some kind of indentation there where you have the queries or evidence associated to that. And sorry, the here is in Portuguese. I didn't have enough time to actually translate everything to English. In the paper, I do some translation, say, oh, this means that, and so on. But unfortunately, I didn't have enough time for the presentation. But basically, if you look at my chapter 5, my PhD dissertation, you have all these queries and evidence there, and they're the same, which I added here. But the use case was actually created before we had the tool. So what I do is show how much easier it would be if you had the tool, so you wouldn't get lost and that kind of thing, right? So you can, and I call them hypotheses instead of goal, query, and evidence, because remember I said that the, evidence to a query could be another query, and so on. So I just call them all hypotheses and just link them together. We also want to have all these entities and attributes and relationships that we have associated. We also want the relationship, we're not mapping domain and range, but we're saying, okay, it depends on person, and it's also related to enterprise. In the future, we would like to be, to actually have some kind of lightweight ontology here, that we could say that the domain is this, the range is that, something like in that sense. But remember, we're more worried about documentation so far, and not really creating the ontology. We also have ways to define rules. So again, this is just a description of the rule. But then you can say this rule is tied to this other rule. And you kind of can make a reference inside the rule. You can make a reference to another rule. So remember when I said that if two people live in the same address, it's more likely to lower the competition for that procurement. So that's one rule. But that rule can also be referred when you're saying, if that happens, or that rule happens, then it's more likely that the procurement is suspicious. So see what I'm saying? I'm like using the other rule to create a new rule, right? So that's how we do some rule traceability. And this rule is also associated to goals and evidence and query. So you're kind of keeping track of all these branches, right? Where things are going, and not on the floor, hopefully. And we have the same thing for everything I talked about before. So you can also do the grouping of these entities and properties and rules into different groups, right? And you can call that specific, give a name to that group, and then say, okay, this is how I'm going to group these things to make my life easier when I have to implement them. Okay, and then finally we have the traceability, saying that, okay, if I have this change in the requirement, what's going to be the possible impact on the other things that are implemented? So you have defined 1,000 different elements. But from these 1,000 different elements, it's just going to have some impact in 50 of them, right? So it helps you keep track of what might happen, right? Of course, this can get really ugly itself, but it's a start. So this is still a beta tool, and it could get better, but that's how far we got so at this point. So some conclusions is that, well, it's the first implementation of this. I'm kind of, well, I proposed it, so it's kind of natural that this happened. But it was actually a work of an undergrad student that did this implementation with the help of other people also. But also, as far as we know, it's the first tool and also method that deals with how to model this, how to create these difficult models, these complex models, right? So this tool seems to be the first that tries to deal with that, at least as far as probabilistic ontologies goes, right? As tools for designing ontologies, we have plenty. But for how to model probabilistic ontologies, I think it's the first. So, it overcomes those problems I talked about, provides a centralized tool for documenting probabilistic ontologies, keeps you focused on the things that might change. So, be careful what's going to happen in the next iteration, because you're adding new stuff, and this stuff is going to impact that rule and so on. And as future work, of course, we need more tests, more use cases, and make sure this actually works when we create a use case from start, right? From scratch, and not just use it after we have the use case, which was this case here. But we also would like to have something like exporting all this documentation to a single HTML file, because there it's just like putting things in a database where you add a new entity, you add a new property, and you have all this information separate, right? But they're tied together, but would be nice to have a report in the end, say, okay, this is how my model, my documentation is for this specific model. And also, something it's doable, we haven't done yet, is to actually get those groups we have. And from those groups and the rules we have in it, we could create a structure for the mfrags that I showed. So I could try to identify, okay, here he's talking about this predicate, right, about this function. So this is going to become a random variable. And this random variable is associated to this other random variable. And it's if this random variable, then the other random variable. So I can use that to say that it's going to have an edge between this random variable and this other random variable. This is not simple, but it's doable, right? So that's something we would like to do to help people, especially if you're not familiar with Mebane and all these random variables kind of things. If you have something started, right, you can look at it and say, okay, now it makes sense. Now I know where to go. So I can fill in the probabilities. I can define the ranges and property of things, but at least I got something started. And I could even create a lightweight, a really simple ontology that would at least have the properties and the classes. And later on, you could say, okay, this is a subclass of that, and so on. But, we would like to have something in this sense. Of course, we would have to do the other way around. So if I make changes to the model, how does this impact the documentation? And that's a whole different level of problems we have, which is not solvable even for software development, which has been there for a long time. But also, we would like to see how this applies to different probabilistic ontology languages, just to see if it actually helps create other models, right? Can I actually apply this, as I say in theory, I could, and create models for other languages, right? So that's something we want to try too. Well, thank you very much.